Sorry about that. I don't know why this is happening. Okay, so the rate is made up of two different things, right? So it's made up of the speed of the boat. So I'm going to put boat speed. But then whether you're going downhill or up or downstream or upstream, that's going to be, the speed of the current. So I'll say plus or minus the speed of the current. All right, so I've got to, on this rate part, I've got to have this, something plus something or something minus something. So let me show you when I set this up so I am going to still set it up kind of in a little chart. Okay. And the thing that I know about this is I've got downstream, so I'm going to have an equation where I'm dealing with downstream, and another equation dealing with upstream. Okay. And then I know that I've got information about the distance, the rate, and the time. And those are the things that are going to help me build these equations. Okay, so let's look and see what we know here. Okay, so the thing that it's asking me so it says find the speed of the boat in still water. All right, is the specific thing that I'm trying to find. So I know that's one of my variables that I've got to define there. And so maybe on this one, I'll just put B is the speed of the boat. Just put it as boat speed. Okay, that's the variable I'm going to use for that. And then when I look at this closer, am I given any information about the distance? I've got 3 hours, 5 hours, 6 miles per hour.
6 miles.
Yeah, so we don't know what the distance is. So that's where my other variable is going to be. So I'm going to say D equals the distance. Okay, it's not giving me anything there, so I know that has to be one of my variables. So these are both going to be D. Okay, now my rate, again, I've got to go over here. It's the boat speed plus the speed of the current, right? Well, I don't know what the boat speed is. That's my B, and so I've got to have my B plus or minus my current speed. Now let's think about this. If it's downstream, if you are going with the current, is that moving the boat faster or slower?
Faster is plus.
Faster. So we've got to put a plus on this one, right? Plus the 6, because that's how fast the current is going. So however fast the boat's going, plus 6. Okay. And then my rate for my upstream, well, if I'm going upstream, then it's really slowing me down, right? That current is slowing me down. So this is going to be B minus 6. Okay. And then the time I'm given on here. So for downstream, that's 3 hours, and 5 hours is upstream. Okay. And now I can make these two into some equations, right? So this top one, remember, it's distance equals rate times time. So D equals, and then I need to multiply these guys together. And I'm going to write it this way, 3 times B plus 6, because it just looks weird to me to have that 3 on the other side, right? I'm going to end up having to distribute there. And then my other equation, right, is going to be, write it here, is D equals 5 times B minus 6. Okay, so is everybody following me there to that point? How to get that set up? Okay, and then from here, right, I mean, I'm looking at this going, okay, well, I probably need to distribute that through there, so let's do that. D equals 3B plus 18, and then distribute the 5 through. I get D equals 5B minus 30. And then I can put these guys, now I can decide whether I'm going to use the substitution or the elimination method. Well, notice I know D equals all of this, right? But D also equals all of that. So really, I'm just taking this and putting it in place of D here. I'm like setting the two equations equal to each other. And that's really similar to what you did on the car comparison project, because you had it like in that y equals mx plus b form, and then you had to set the two equal to each other. So that's what I'm going to do here going forward. So I've got 3b plus 18 equals 5b minus 30. And then I can get, I'm going to choose to subtract my b's this way. So that's going to give me 2b. And then I'm going to add my 30 over this way, which is going to give me 45. I don't know what happened here. 48, sorry. I don't know what I was doing there. Okay. And then I divide by 2. So B equals 24, right? And then again, I'm not done, right? I need to put a word answer on it. So 24 what? What was I trying to find, right? Remember, B is the boat speed. So what label do I need on that? 24 what?
Boat speed downstream.
Yep, so is it like kilometers per hour, miles per hour, meters per hour? Yeah, it's miles per hour, right? And that's because we know that it's giving us, something in hours, and let's see. I thought it gave us something on there about, I guess it didn't really say, but it will on the one in the test for sure. You'll know whether it's, miles per hour or kilometers per hour or whatever. Okay, and that's all it's asking us to do, right? Find the speed of the boat in still water. So that's the speed of the boat is 24 miles per hour. So that's all we need to do. Okay. All right, so make sure you practice up a little bit more with those kind of story problems if that's something that has given you a little bit of, problem. I definitely want to make sure that you know how to do those types of story problems before taking the test. Okay, number 11, we have 3 equations and 3 variables. And on this one, I think these are so fun. It's just kind of like a little game to me on it, but you got to know, kind of the steps to take in order to make it any kind of fun for you. All right, so I like to label these as equation 1, equation 2, and equation 3 as I'm explaining it, just so you guys know which equation I'm talking about on this. Okay, so we want to take 2 of the equations to start off with, and we want to try and eliminate one of the variables. So sometimes I look at it and see, is there, something that would be easy to eliminate? And so if I look at 2 and 3, right, I've got a 2x and a 2x, and I've got a z and a z. And so really, I just need to make one of those equations negative, and then if I add it to the other, I'd be able to get rid of that. So that's kind of what I look for, first when I'm trying to solve this. But you can do it any way you want. It doesn't really matter on that. But if I take equation 2 and equation 3 and say I decide that I want to get rid of the x's, right? So I'm going to take that first equation and I'm going to multiply it by a -1. And then the second one, I'll just be leaving the same. Looks kind of weird. All right, so really, and I'm going to rewrite this down here after I, distribute that negative through. So I get -2x minus 3y minus z equals -6, right? I got to make all of those negative. And now when I add these together, I can see that I get rid of my x's, right? Which is what I was trying to do. However, I got rid of something else as well, right? I got rid of the z's also. And sometimes people get freaked out by that when they're like, oh, wait a minute. But it actually makes the problem a lot easier if you're doing, if you can do that. Okay, so here I've got, I'm going to add these together. So I've got negative 4y equals negative 20, and I'll divide by negative 4. And so I'll get y equals positive 5. Okay. Now, when I'm looking at this, right, I know what y is, but now I'm trying to figure out, okay, how do I, figure out what the other things are? Well, I've got to look at two other equations and again, try and eliminate that same variable that I did before. So you need to eliminate your x's or your z's. Okay, either one is fine on that. So I'm going to look at equation 1 and equation 2. And, so on this one, do you see on equation 1, I really need to multiply that by a negative 2 to make the 2x and the negative 2x eliminate out. So I'm going to do that here. So I've got negative 2x minus 2y plus 6z equals negative 8. All right, so I just took this, distributed that negative 2 through, and I wrote it here. And then my equation 2 is 2x plus 3y plus z equals 6. And now I will I'll add these together to see what I come up with. So my x's are gone, which is good. I was trying to get rid of my x's. But then what I'm left with, when I add these together, negative 2y plus 3y is just y. And then I add those together, get 7z, and here I get negative 2. All right. And now I can use this y equals 5, right? I already found one of my solutions, y equals 5. And so I can use that and put 5 in place of y here, and that's going to help me find z. So let's do that. So I have 5.
So, question here.
Say that again?
Excuse me. Just I have a question.
Yeah, you bet.
So, do I have to write here, I'm going to substitute y in this equation?
No.
Or I don't need to write this?
Nope. Just kind of keep your work organized so I can, see exactly, what you're doing, but you don't need to like write in words, any of the steps that are happening there. You can just, your work is how you're communicating to me what you're doing. So I'll be able to follow it. Okay, so 5 and then plus 7z equals negative 2. Well, let's subtract that 5 over. Get 7z equals negative 7, and then divide by 7. So z equals negative 1. Okay, so I found 2 of my answers. Now I'm going to write them over here as an ordered triple. This just helps me keep organized, right? So I know my y is 5 and my z is negative 1, so I still have x to find. How can I use these two things to help me find x? What can I do there now?
Substitute y and z in the equation.
Yeah,
Like
which
an
equation?
equation?
Does it matter which equation I use?
No.
No. So I'm going to choose the easiest one. And that first one looks like the easiest one to me. So that's the one I'm going to choose to use, right? So that's what I'm going to do here. So I'm going to have x, which is what I don't know, plus y, so plus 5, and then minus 3z, so minus 3 times negative 1, and then equals 4. And now let's just kind of, simplify this up here a little bit. So when I simplify that up, I get x equals negative 4. All right. So negative 4, comma 5, comma negative 1. I found my x, y, and z now. And that is my answer. Okay. And it seemed like on the quiz for this, you guys did a really good job on that 3 equations, 3 variables. Some of you are trying to use the substitution method instead on this. I mean, and you can, it just usually gives you weird fractions and it just makes it a lot harder because you can make like so many mistakes with the fractions and stuff. And the other thing that I wanted to tell you is on the test, like this is an important thing to know. For any of these, so these 3 equations, 3 variables, or just the other type that we did up here, the substitution method or the elimination method, right? I will never, those will never come out to be fraction answers. They're going to be whole number answers. So if you come up with a fraction, that should clue you in that you're like, oh, wait a minute, Becky said she's not going to, these aren't going to be fraction answers. So I must have done something wrong in my arithmetic. And that way you can go back and kind of look and see. Because I'm not trying to test you on, fractions so much on this as I just want to make sure you know how to do, these types of problems. So whole number answers is what you're going to be given there, right? Integer answers. Okay. Questions on that?
Yeah, I have some question about this.
Yeah.
1, 2, 3 that we just solved it.
Yeah.
My question, I heard you said, but I just wanted to confirm it. Doesn't matter, right? For if I use like the 2 and 3, and then I use the 1 and 3.
Yep, it doesn't matter.
The result gonna be the same?
It is going to be the same as long as you always eliminate the same variable. So I eliminated the x's here, and I eliminated the x's here.
Yeah,
So
I follow the homework show. I always eliminate the z first.
Yeah,
And
that's
then-
fine.
Yeah, and then some kind, I don't know, maybe I then after that, I have to follow them like the equation 4 when I got the result.
Mm-hmm.
And then after that, I have to find x or y,
Mm-hmm.
and I use the same 4 and 5.
Yeah. You put the 4 and
Yeah.
5 together and
Yeah.
get rid of one of the other. Yep.
Mhm.
And that's usually the way it happens. It just on this one, we
Yeah.
we ended up with 2 variables, getting rid of, and so that's kind of a little bit different.
Then I follow on the video, and then that's like right now you explain, and then I just want to make sure from 1 to 3 doesn't matter when I use other one.
Nope, it doesn't.
Okay.
It doesn't.
Okay, thank you.
Yeah, good question. Yeah, that is really good to know, right? So yeah. Okay, just a few more questions here. I know, like I said, I was going to end at 11:30 and we had some technical issues and stuff, so we are going to be going a little bit over, but hopefully if you can't stay on, I understand and you can watch the rest of this later. I'm sure hoping that all of these videos will saved because I don't know why they just unexpectedly quit. So, okay, so let's go through these ones really quick though. Okay, so to write this as a compound inequality, I want to make sure that you see that when you read this, this reads as x is between -8 and -2, including -2. All right. And so the part that I want you to make sure that you understand is it's saying it is between, right? So we know our answers are going to be, between this number and this number, like it's got to be in between that. So when I'm writing this in interval notation, right, I'm saying, okay, well, if x is the stuff all in between it, let me write my little number line because sometimes that helps illustrate it a little bit better. Here's -8 and here's -2. And we want all of the stuff that's in between here, right? It includes -2, so there's a closed circle there, but it doesn't include -8. Notice that it doesn't have an equal sign on that part there. All right, so that's an open circle there. And so to write that into interval notation, we're reading it from left to right. So open circle means parenthesis, -8 to -2, and then that closed circle means it's going to be a bracket. All right, And so all the stuff between -8 and -2 is how we write that. Okay. All right, on this next one, we're solving an absolute value. And when you're solving absolute value equations, you've got to get the absolute value part by itself first, and then you're going to write two statements. And that's the part that sometimes students forget. They'll solve it, this way, but forget that they have to write another statement, right? So the two statements that you're going to be writing is you're going to take off the absolute value sign once that absolute value part's by itself. So I've got 2x minus 3 equals 4, right? And then the other one is 2x minus 3, and then we're going to change that to a negative, equals -4. Now, sometimes on the videos and stuff, they'll change this side, right? They'll make that -2x plus 3 equals +4. And that's the same thing. You just have to make one side or the other negative. I just think it's easier. We have one number there, just change that to its opposite. It makes it a lot easier to solve. Okay. And then I'm just solving these two equations down, just like you've done a lot of times before, right? So 2x equals 7, and then divide by 2. So x equals 7/2. So there's one of my solutions. Then let's add the 3 over. 2x equals -1, divide by 2. So x equals -1/2. Okay, so the important thing to remember on this is when you have absolute value equations, you're going to end up with two solutions. Okay, because we don't know with an absolute value, remember, like if we take the absolute value of -3, the answer's 3. If I take the absolute value of +3, the answer's still 3. So I don't know which way it's, like what I'm dealing with. I've got to look at the positive case and the negative case when I'm dealing with absolute value. So that's why we're doing those two statements. Okay. All right. And I'm going to, didn't leave myself enough room on this number 14 here. So I'm just going to kind of move it out here to be able to work this a little bit better for you. So I've got the absolute value of x minus 4 plus 5 is greater than 10. Okay, now again, we've got to get that absolute value part by itself, just like, this one already had it by itself, so that made it easy. But this one, in order to write our two statements, we got to do that first. So I'm going to start by subtracting the 5 over. All right, so I've got the absolute value of x minus 4 is greater than 5. Okay, so whether I'm dealing with an inequality where it has a greater than or less than symbol, or if it's an equation, right, I still am going to start these out the same way. Okay, but now this is where I'm going to write my two statements. I've got that absolute value part by itself, right, and my first statement is just like it's written here if I remove the absolute value bar. So x minus 4 is greater than 5. Okay, and then my other statement, I leave that x minus 4 the same. I have to flip my inequality sign so it's no longer greater than. All right, I'm going to make this red just to make sure it stands out that I flipped that. And I need to make 5 into its opposite, so it's -5. Okay, so I kind of changed those two things in red just to hopefully make them stand out to you, that I had to flip the inequality and change the sign. Okay, and then another thing, and since I don't have you guys in my class, I usually give like a little way, like an in-person class, a little way to help remember like whether these are and or statements, because that's important. It's going to change our answer whether this is and or. And so let me just kind of write over here. So if I have a greater than or equal to, I want you to think of this as greater, right? So it's an or statement. If I start off, so when I get to this point, and I have that absolute value part by itself, I'm looking at this symbol right here to tell me whether it's an and or an or statement. If it's right there instead was a less than or equal to, then you can think of it as less than. Okay, and again, this is just a play on words to help you remember whether it's an and or an or statement, because that's usually where people make mistakes on this. So since this is a greater than symbol on this, then that means it's an or statement. So I'm going to put or in between here to remember. That's going to come in handy, or we need to know that a little bit later after we solve these. Okay, so let's finish solving these out here. So if I add the 4 over, I get x is greater than 9. And here if I add the 4 over, I get x is less than -1. Okay, and now write this on a number line. Even if the instructions here, I mean, this one says to solve and graph. It'll also ask you to write the answer in interval notation as well. But sometimes it doesn't tell you to graph it, but always graph it. It just makes it easier for your brain to see what's going on. So -1 is somewhere over here. +9 is on this side. All right, and so let's just make these, I'll do these into 2 different colors to make it a little bit easier to see. So x is greater than 9 is going to be an open circle there and everything bigger than it. And then the red, I'll do this one in red. So x is less than -1, so open circle here and all the stuff smaller than it. So all the stuff that way. Okay. So remember, this is an or statement. And so then as I write these down, I'm writing it down from left to right. So the furthest to the left this goes is out to -infinity and then to -1. All right, and it's an open circle, so it's a parenthesis there, but that's not all, right? We got all this blue stuff over here too, so I've got to put union and all this other stuff. So parenthesis 9 to infinity as well. And so that would be your answer on that. Okay. All right. So yeah, just really, watch these carefully. One thing that I also want to, point out that sometimes is, I guess, a little bit tricky sometimes for people is just, actually, I don't know. I'm not gonna go there because I don't want to confuse you. I think just, do it this way. Get that absolute value part by itself first. Decide whether it's an and or an or statement. Graph it. Or means everywhere those 2 graphs show up, right? And means the overlap of it. So I guess the only thing that I would say is if this was an and statement instead of an or, where are these guys overlapping?
Between -1 and 9.
Are they? Are they overlapping there?
No.
Oh, well, I guess had it been. Never mind. No,
Yeah.
they're not, so there's no.
Yeah, so it would be no solution is what I'm trying to get
No
at. You're
solution.
right. Yeah, so if this was an and statement instead of an or statement, there's no overlap. And so that would be a no solution. So I guess I just want to make sure that that's clear to you as well. Okay. All right.
I have a question
yeah.
about that.
Mm-hmm.
Can we solve it with different way? Like, what I do is to write -5 greater than x -4 greater than 5. And I got the same solution. Just write like
no, because that's giving you an and statement. And so you would really be, your answer would be like saying the stuff in between here, kind of. You don't want to write it as an and statement. So you're saying like -5 is greater than x -4, which is greater than a 5. Is that what you're saying? Yeah, so this is an and statement. So we would be saying all of this stuff in between there would be our answer. So we don't ever write or statements this way. This is an and statement. So if this was going the other way, then yeah, you would. So
but when I did it, it gave me the same graph and the same solution. Because when after I subtract from both sides, I get here -1 greater than x, which means x less than -1, and go to the left direction, and x greater than 9 is going to be to the right direction. So it gives me the OR graph, right?
Well, I mean, I can see what you're saying. If you separated these guys out, right, then you'd
Yeah.
get this. But this really says x is between those two numbers. And x isn't between those two numbers. It's everything else, right? So if you looked at it separately, right, and that's why I write it down separately, because really these two are separate on here. I can see what you mean, and and if you kind of explained in words what you were doing there, you could do that. But technically, mathematically, it's not correct to write it this way unless this started out as an and statement. But I can see what you're saying. You're getting those same numbers. If you were to graph those separately, then you get this. So
yeah, because I used to use this way and give me the correct answer. I did like that in written tests.
Yeah, so I guess if you do it this way, then just show me you're doing these two things separately, write those out separately, and then do your graph and your interval notation.
So I can use this way?
I'm saying you can, as long as when you get to this point, you write them out separately. So here, this is really written as x is less than -1, and then this is x is greater than 9. So as long as you're writing them like that, and then graphing them from there, then you would get full points.
Because the first way make me confused to do it, and always make mistakes when I do it, so I prefer the second.
Okay, yeah, but just make sure that you write it out separately, because technically it's not mathematically correct, because we don't have that. X is not between those two numbers, okay?
Yeah.
All right, and then this one is just graphing a system of linear inequalities. Really, on this, you just need to remember to I think it's easiest to put this into y equals mx plus b form, right? So get the y by itself, so I'm subtracting the x here, so I get y is less than or equal to -x plus 6. And then this other one, if I subtract the x over, I get, let's see, let's write it this way. So I've got negative y is less than or equal to -x plus 4. Sorry, that's looking like a mess there because I ran out of space. Okay, and then it's not done. Our y isn't by itself yet. We still need to divide everything by a -1. And remember, when I divide by a negative, that flips my inequality the other way. So y is greater than or equal to +x minus 4. And then you're just graphing the two on here. I'm going to do these in 2 different colors again, just to make it a little bit easier. So I'm going to start with my y-intercept, which is 6. So 2, 4, 6 is there. And then this -x is really -1 over 1, right? So I'm going down 1 over 1, down 1 over 1. And so it's kind of looking like this. And, I wanted to make one of them. I'm going to change this other one so it's just a less than and not a less than or equal to. And so that on this, it would make it a greater than. Okay, just because I want to make sure you see the difference on this. So if it has the equal to part, then it is a solid line, right? Like this. But it's not just this line, it's all of the stuff less than or equal to the line. And so the stuff less than the line is all of the stuff below it. So it's going to be all the stuff here. Now, if you choose to do a test point like they, explain to do, like pick 0, 0 and see which side is shaded, that's fine. But if you can see in your mind, this is saying x is less than or equal. And if it's less than, that means it's below the line. Right? Where if it's greater than, then that means it's above the line. Okay, so on this other one, let me graph this one here, because that's not all. We're not done yet. We've got to graph this other one. So -4 is right here on my y axis, and then my x is +1 over 1. So up 1 over 1, up 1 over 1, and so on. But this time, I've got a dotted line, all right? And then, I should probably take that out just a little bit further there. And then this, we want all of the stuff that's greater than that line. And so the stuff greater than the line is the stuff up here. All right, but our solution is just the part that they have in common. So do you see it's just kind of this little pie slice looking piece here, right? And so on the test, I'd rather you just, just shade in this part, or just make sure it's darker. I just want to know, really clearly that you see it's where the overlap is our answer. Okay. The other, like this part above here and this part below there, isn't part of the answer because it's not part of the overlap. So just where I have the green would be our answer. Okay. All right, there's just a couple of other things that I didn't put on here that I want to make sure that is clear, just to, I want to talk about domain and range a little bit if we're looking at a graph. Okay, so say that I have the graph, oops. A graph that's kind of like this sideways looking parabola, right? That looks like that. So if I asked you to write the domain and range for this in interval notation, okay, so the domain is all the x values. So that's looking at the graph from left to right. That kind of up here to help you remember, right? Look at the graph from left to right. So where's the furthest to the left that this graph is?
-3?
Yeah, -3, right there. And so, and it includes it, right? It includes that. So I'd have bracket -3 to where?
Infinity.
Yeah, because those arrows are telling you it's going out forever, right? If it gave like a stopping point instead, right? So let me just kind of do something like this in blue. So say that I had, it was like this, and then like this, and say that this is, I'll say that that's 2, right? Just so we don't get confused on the other thing. So if it didn't have the arrows, right, but it told you gave you segments instead, then you'd say, well, that's -3 to +2, right? So watch to see, does it have the arrows or does it not? Because that's going to change your answer a little bit, okay? And then the range, you're looking at it from bottom to top, right? So bottom to top. So I'm just saying, okay, like how far down is this going to go? So if it had the arrows on it, it would be -infinity to infinity, because it's going to go down forever and it's going to go up forever. Okay, but again, if I look at this, on this one, they'd have to be giving you, some things here. Wait a minute, that's going to be kind of 3 there, it looks like. So on this one, sorry, my graph isn't great, but it would be -3 to +3 is where those would end up being. Okay, and again, with those brackets. So just make sure you can look at a graph and, find the domain and range if you are given a graph. Okay, make sure you know how to do that. Something like that oftentimes shows up there. And then if you're asked to graph something that's not a line, just a straight line, I do highly recommend that you use the table of values. You pick x's and find the y's. right? So like if you had something like y equals the, we'll say like the square root of x minus 5, right? So I want to choose values for x and values for y, but it's kind of like, it's a little bit different on these square root graphs, because it's going to be kind of hard to tell where the starting point is unless you figure out, you know, where this is going to be 0. And so do you see like 5 is where, like if I do 5 minus 5, that's going to give me 0 there. And so that's kind of what, you know, where I'd want to have my starting point. And I can't do numbers that are smaller than it, because see, if I put 4 in there, 4 minus 5 is -1, and I can't take the square root of a negative number, right? So I can't do numbers that are smaller than it, so I'd have to pick some numbers that are bigger than it. So if I put 6 in there, 6 minus 5 is 1, square root of 1 is 1. Okay, and so you do just a few points there, but then you could see, okay, over 5 up 0 is here, over 6 up 1 is about here. And so, and if you did more points, you kind of see that it looks something like that. Okay, so if you're given something other than, you know, than just a straight line to graph, I highly recommend you pick some points. And on this one, where if it's a square root, figure out where, you know, what x value is going to make that whole thing 0. And that will make it a little bit easier to tell where that graph begins, because this graph does not go down below, right? I mean, there is no, like, it has a starting point, and it's here, and it goes out to infinity that way. Okay. And then I guess the last thing that I wanted to say is about, I want to make sure you understand how to find the domain, you know, of this as well. And you can see, if you, after you graph it, you can see what the domain is, right? It's 5 to infinity. But if you were looking at this and trying to tell what the domain is before you graphed it, which is good to know because then you know what x values you can pick, then you take what's inside. So we're not taking the square root part, just take whatever's inside that x minus 5, and it has to be greater than or equal to 0, right? Because we can't take the square root of a negative number. So when you're finding the domain of this, you've got to say, okay, I have to say it's greater than or equal to 0, whatever stuff's inside. So I add the 5 over. So x is greater than or equal to 5. All right, and then if I write that in interval notation, that would be bracket, because it has the equal to part, 5 to infinity. All right, and I can see that here. It's 5 going clear out to infinity. Those are all my x values it's going to have. Okay. So just again, if you're finding the domain of something inside a square root, you're going to put it greater than or equal to 0. But remember up above where we found the domain of something that was a fraction, on ones like that, we have to put it not equal to 0, because we can't divide by 0. Okay. So keeping these two things kind of straight in your head is really going to be important on this exam. Okay. All right, well, that is all I've got for you today. And if you want to stay on and get any other questions answered, I'm more than happy to stick around for a little while and, you know, help you with that. And I just wish you all the best on this. Remember, I mean, you know, make sure if you haven't signed up to do the test, get it done, because sometimes they fill up and it can be really hard to get into if you wait too long, right? But you can take it today, but you can also take it Monday and Tuesday, right? right? So those are the days that it's available for you to take. Okay, guys, I will hopefully see you at another time, another review session, or come see me my office hours. I'm usually just sitting here waiting for people to come by and ask me questions. Okay, have a wonderful day, but stay on if you have more questions. I'm happy to help you.
Thank you.
You're welcome.
Thank you.